Thank you everybody for joining us in this webinar. My name is Bryony and I'm here to show you through the new features in the latest release of EchoView. So EchoView 10 was released in May this year and it includes a great collection of new features that we'll work through today. I'll provide demonstrations of the list on the screen during this webinar of some of our exciting features. But of course there is a lot more in the release as well. So we'll start with looking at line-referenced echograms. So the line-referenced view is an option in the echogram display page of variable properties, and it can be used with the bottom line in order to speed up checking the success of the bottom line detection algorithm, but you can also use any line at all that you like as the reference line. And when we've got this option enabled, we can define and edit lines, and we can also define regions, but we can't edit existing regions. And so I'll show you how to do this in EchoView now. So I have an EV file that I've prepared previously. So this is just some typical echogram data with a bottom line detection. And so to set a line referenced echogram view, we go to variable properties for the echogram, and you can do this via right-click variable properties or via our shortcuts or other buttons that we have available. So in the variable properties dialog, we have the echogram display tab. And on the echogram display tab is this new setting that I've highlighted here. So this is the echogram reference line, where we select the line that we want to make the echogram relative to. So in this case, I'm going to choose the bottom line that I've created and press OK. And our echogram updates. So this line is now flat, and all of the pings have been adjusted relative to that line. We can then zoom in on a section of our echogram. We might see a little bit of line editing that we need to do, so we can use our bottom line editing tool. We could change that, update the active line, and everything will adjust accordingly. We can also look at the original data at the same time as the line reference data by creating a copy variable. So if I go to my data flow window and create a new variable, and I want to create a copy, press OK and OK. And then in one of these variables, I can change the echogram display, echogram reference line back to none. And so now we're looking at the same data in the two different views at the same time. So this could be really useful to synchronize with our synchronize button, auto synchronize button at the top of the window. If we turn this on for both of our echograms and then zoom in on some of our data, we could scroll across, check our lines, and make line updates as we like to see the results instantly in both views. So that's the line referenced echogram. We've also added a number of new analysis variables in EchoView 10, and the first that I'm going to talk about are our altitude analysis variables. So altitude measures the distance between a region and the exclude below line that you've set for that variable. And so I've just generated an example on screen here to show what's being measured for these new analysis variables. So on the screen I've got a region, which might be a school or some other aggregation. And I've also got an exclude below line, which in this case is the bottom line. So I've detected and excluded the bottom. So the first of the new altitude analysis variables is region bottom altitude max. So this is measuring the maximum distance between the underside of the region and the exclude below line. Region bottom altitude min, this is the shortest distance between the underside of the region and the exclude below line. And region top altitude max, this is the longest distance between the top of the region and the exclude below line. Region top altitude min, so the shortest distance between the top and the line. And then we also have mean, we also calculate mean for both, which is the mean distance for all pings to the top and the bottom of the region. We've also added some new analysis variables that sometimes have been referred to as echometrics. So there's a paper from Ermi, Horn and Barbie at the University of Washington at the time. They identified a suite of metrics that were really useful when characterising variability in pelagic backscatter. So EchaView 10 adds the remaining metrics that weren't available in EchaView as listed on the screen here. So I can show you where you can see these in EchaView. If we go to our EV file properties dialog, view EV file properties, or we can use the button or the F6 shortcut key. On our export page is where we'll find all of our analysis variables that are optional. You can choose whether or not to include these. So the echometrics analysis variables are found under integration results. So if I expand this, we can see we have proportion occupied, centre of mass, and the others as well. By default, these are turned on, but we can choose not to include them or to include them if we like. And under analysis domain, we have our new region altitude variables down here. So these are the 6 that I showed before. So we can turn them on and off as required. And what we can also do with these new variables is region classification. So I won't go into region classification here because this isn't an EchaView 10 feature, but what I will highlight is we can use this to automatically classify our regions based on their properties. So in this case, I could run a region classification to identify anything that's close to the bottom and set it to being a benthic region class. So in this case, I've set it to say if the region bottom altitude minimum is less than 5 meters, then I want to class it as a benthic region. So region classification can be really useful for especially these altitude variables. The next 2 topics that I'm going to cover are the code operator and the command interface. But before I get into those, I just wanted to clarify scripting in EchaView because sometimes it gets a little bit confusing with lots of references to scripting and automation and code. So I just wanted to summarize this to help to understand what we're offering. So to start with, a script is a computer language that contains a series of commands, and scripting is a type of coding. But these words of programming, scripting, and coding are sometimes used interchangeably. In EchaView, we have and have had for quite some time now COM automation. So this is using a COM interface to control EchaView and to automate data processing, and it's part of the automation module. And for COM automation, you can write scripts in any computer language that can create any COM objects, and this is most that anybody is very likely to use. It includes MATLAB, R, Python, VBScript, many other languages as well. So in EchaView 9 and older, our COM model has an extensive hierarchy of objects. It can be a bit complicated to use, and it's a bit challenging for us to maintain as well. So in EchaView 10, we've added the command interface to COM, and it's simply a new method called exec, and it sends a command line string to EchaView. It's very simple to use. There's no hierarchy to have to learn, unlike our other COM interface methods. And it's very easy for us to maintain, so we can add more stuff to this much more rapidly. It also includes the interactive console dialog box. So COM, including the new command interface, is used to interact with EchaView and automate data processing via scripts. But the code operator, it reads Python scripts that contain custom algorithms, and these results are then available as echograms for further analysis. And this is part of the advanced operators module. So to summarize these, COM, including the command interface, is used to automate data processing, and the code operator is used to write custom algorithms that you can manipulate your data with. So hopefully that helps to clarify the 2 topics. So looking at the code operator, it has a built-in Python interpreter and can be used for custom algorithm development. So EchaView can be used as our tool to read data files and Python files can easily be shared between EV files and other users as well. We've recently posted an example on our website, and I'll show you this now. I'll switch to my browser. So if you go to the EchaView website, Our most recent news post currently, it might be a bit buried down by the time this is published on YouTube, so if you're watching this later, you might have to dig for it. But we've posted a news post about the code operator and how you can use Python scripts to subsample data. In the paper that's referenced here by Levine and De Robertis, the authors show the potential of subsampling to make data processing much more efficient. EchoView has a ping subset operator, but if you're doing a lot of subsets or a regular interval of subsets, it's not very useful. So the authors use MATLAB to generate and create new data files that only contain the subset of the original data that they were interested in. But now that we have the code operator, we can really easily do this in EchoView. And the example code that we've provided in this news post shows us how, but I'll just quickly run this through in EchoView. So I'll just close this file and create a new file. And I'll add some data. Just a bunch of Eco60 raw files. And I'll look at the echogram. So we've got about 6,000 pings in this example. So to create a new code operator file, a variable, in our data flow window, we go new variable and find the code operator in the list. Press OK. EchoView will pop up a quick warning. Essentially, this is because we can include scripts in EV files now, and we just want to make sure that it's safe to use and give the user the option to choose whether to trust a script that's included or not. I'll say yes. And then we have the code operator page. And this is where we can tell EchoView where to find our Python source file and also the window size to use. I'm going to create a new source file. Give that a name. Oops. And that will open the file that's created, but I'll come back to this in a different program. So I'll just press OK and view that echogram at the same time. And we can see for the moment it's identical as the original data. Now I'll just have a look at this file that I created in Notepad++. So EchoView will create a default template when you create a new Python file, which contains some useful information to help you get started with the types of things that can be found. And so by default, the script that is created, it works, and it's basically the data is exactly the same as the input data. I'm just going to delete this because I'm not going to use this example, and I'm going to copy the code from our news post. And paste that here. And once I save this file, EchoView will recognize that the script has been changed and it will apply what we've included. So you might have noticed here, the bottom right corner, we've now got our subsampled data. So the script that we've used here is telling EchoView to return the first 50 pings out of every 500. So those 50 pings are still displayed, and in between, we've turned all our data into no data. And we can then use the reduce pings variable if we wanted to remove the no data pings. And we've now got our much shorter echogram. So this is useful for subsampling. It's a pretty simple example, but it's quick and easy, and it's not something that we could easily do in EchoView previously. The EchoView help file also contains some other examples to help you get started with using the code operator. So on the help file page called Using the Code Operator, the bottom of this page is example scripts. So we've included 5 examples so far of different scripts that you can copy and paste into EchoView and experiment with and see how it works and the syntax and so on. So bitmaps to look at dusk and dawn times. We're calculating factors to do with the Sawada index. Z-score, multi-frequency, backscatter classification. We've got a script for diagnosis, so this is just some tips and tricks for finding issues when working with this Python operator in EchoView, and a cubic cross filter bitmap generator as well. And we'll expand on these examples with time, and we're also really looking forward to seeing what our users create and share as well, and hope to see this doing all sorts of really cool stuff within EchoView soon to save you having to take data out of EchoView and then work on it in other programs and maybe not necessarily be able to visualize as easily when you're working in MATLAB or other software. So that's the code operator, very exciting. Moving on to the command interface and the console dialog box. So the command interface is a new and alternative way to control EchoView. And in EchoView 10, we allow you to read and edit every property for every variable in an EV file. And this is a huge advantage over traditional COM scripting, which only has access to some of the variable properties, but not all. The console window, which is shown on the screen now, is a live and interactive way to interface with EchoView. So let's have a look at this in EchoView itself. I'll close this file and I'll open another EV file. It's got a lot of variables already set up in it, two of which I've got open on screen. One of the SV raw variables and a downstream variable as well. So in EchoView for some time we've had what we call the multiple variable properties dialog box. And this is if we select multiple variables in the data flow window, right-click variable properties, we get a cut-down version of the full variable properties dialog box where we can change settings across all variables at once. And we can only do this for some settings, but not all of them. And it's quite handy. We've got some of the more common settings in here, but it's also limited. We don't have access to all settings through this. But we can now do this using the console instead. So the console window, you may have noticed if you've used EchoView 10, it's one of our little panels at the bottom. You can pop this out or move it to the side if you prefer. And we'll just start with a couple of simple examples. If I type variables and press OK, I get a list of all the variables in the CV file, and they're separated by a vertical line character, which is sometimes called the pipe. If I type SV, and now I'm pressing Shift Tab, EchoView will report back what matches, what variables match that the first characters that I entered. Where if I type SV and press Tab, it will start to autocomplete for me. So if I type 1 now and press OK, then I've identified this SV Rawpings T1 echogram that I've got visible. I can press up to get the last thing that I entered. I'll type the pipe character, and then I'll type properties. Press OK. And EchoView will then list every single variable property for this variable in the console window and the values that are currently set. So there's quite a lot of variable properties, all of their values, excuse me. For example, we can see single beam flip vertically, so this is flipping the echogram, is currently set to false. Now, I can change this using the console. So I'll press up to get what I entered last time. I'll start to type single beam F, flip vertically, press OK, and we'll see just for that one setting, the value is currently false. I can use equals pipe and type true. To change that, we can see the echogram switched. If I check what's reported, it's true. I can set it back to false again. So it's flipped back and forth. This is pretty easy to use, but not very exciting at the moment because I'm just doing it for one variable. Why not just use the variable properties? But what I can do now is very easily change this for every single variable in my EV file. There's a few different ways to do this, but let's change it for variables acoustic, properties, single beam flip vertically, and we're going to set them all to true. So this has gone through every single variable in this file and flipped it for me. We can do this for any variable property setting very rapidly across everything. So when you're working with really complicated data flows and wanting to change a lot of settings that aren't accessible via COM or via the multivariable properties dialog box, this will make it really easy. And the command interface can be incorporated into COM scripts as well. So we can combine our existing COM scripts with command interface commands to make this all much easier. And again, we have an example of this on the EchoView website. So on the EchoView website, under technical support, we have a page called example scripts. And on this example scripts page, we've had a lot of scripts here for a while, but the one at the bottom, EV script 16, is our newest one. This one, when you view it, will show you how to combine COM with the command interface to change a whole bunch of settings that aren't available in COM previously. Another use that we've had interest in recently is to capture all variable property settings as a record of use. So where I listed true, false values for all my variable property settings, what it is now possible to do is to report all settings for all variables in an EV file and save that as a text file to use for other purposes if you like, which is kind of neat. Okay, well, moving on to wideband data processing. We focused our energies in version 10 on improving EK80 wideband performance via multi-threading and optimizing some calculations. And so we've done a number of tests on this, and we've seen that the time-consuming steps in data processing were twice as fast in EchoView 10 compared to EchoView 9. So that makes a really positive difference. And outside of these improvements, though, it's worth being aware that performance of anything in EchoView, not just wideband data, but any type of data, is still very dependent on your computer hardware as well. So it's important if you'd like EchoView to perform faster, make sure you've got lots of RAM, you've got a fast CPU, and you're also working with data that's stored in a location with fast read and write speeds. And this will all make a big difference as well. So other new features for EK80 wideband data processing. The first is a complex data export. So in EK80 files, data is stored as real and imaginary value pairs, and from which we calculate the frequency spectrum. In EchoView 10, you can now export these complex values, and it allows you to work with processed complex data like SV in external applications for experimental analysis. So I'll just show you very quickly how this works. I'll close this file. My console back down. And opening up an EK80 data file that I've got, an EV file. So we're just looking at SV pulse compressed data, 95 to 160 kilohertz here. If we go to the echogram menu, export, this is the new option. So echogram export complex data. If we click on this, we get the option to choose to export all data or just a range. I'll just do 10 pings as an example. I'll save my file, continue with the export 6 megabyte file, and then we'll have a look at the file that has been saved in Excel. So this is the export that we get for complex data, and what you'll notice compared to other data exports that sometimes we see is for every ping we have two rows now, one which reports the real values and one which reports the imaginary values of this complex data type. Complex data can be exported from echograms as well as regions or selections too. And the next one that we're going to look at is the wideband frequency response export for FishTrack regions. So this is a way to get summary wideband frequency result information for tracks, fish traces, tracks that you've identified in the data, instead of just for individual targets. So I have a single target detection echogram here. Just pop that to the side. So this is my detected single targets in the same data set. And I'm going to detect fish tracks in this echogram using echogram detect fish tracks. Press detect. So now we can see that EchoView has just identified all the groups of targets that it believes belong to the same individual object across multiple pings. And then our new export can be found in the echogram, export, analysis by regions, wideband frequency response. So this is our new one in EchoView 10. When we click this, we get a number of options. These options are pretty much the same as the options that you have when you look at the wideband frequency response graph. So you can customize what's being exported. In this case, I'm just going to look at the frequency we've got open with the averaged results, default window size. I'll press OK. I'll save the file. That's just exporting now. And we'll have a look at the resulting output. So we can see in this export, we have our metadata, I guess, about the tracks at the top. And then what we've got is a single row for every frequency based on our window size. And every column represents one of the fish tracks. So for region 1, we've got the minimum, the average, and the maximum, and the same for every other region, fish track region that we created in this file. So this is a really good way to further investigate frequency response results for tracks and of fish and calibration spheres and all sorts of things. Now the next thing that we were looking at, we have a new single target detection setting called minimum target separation. And this is quite similar to the option that's provided in the Simrad software. So if we zoom in on some of this data, these targets in this echogram, we can see, synchronize that. What we've got here is probably a bit of a mess with the current settings being used. We've got multiple targets within pings that when we look at the original data is probably from an individual object. And what we can use is in variable properties for the single target variable, we've got our minimum target separation setting. So this is the new setting in EchoView 10. Currently, and by default, it's set to 0. But if I change that to 0.1 meters and press OK, when I press OK, just watch what happens to these targets on the right. We can see that a few of the targets have disappeared. If I now redetect my fish tracks on this echogram, I'll delete the existing tracks and replace with the new tracks based on the current data. We can see that we end up with a single track for this lot of targets, which is probably a more reasonable result, but obviously it's situation dependent. So that is the new setting, minimum target separation. And finally, some other changes for EK80 data in EchoView 10. We've just made some adjustments to calculations. So firstly, the target strength of a target is now calculated using the peak sample in the identified power pulse. And our normalized calculations and settings, and this includes minimum and maximum normalized pulse length operator settings. These now use pulse compressed effective pulse length, which is a more sensible measurement to use, where previously we were using transmitted pulse length. And there's more information about these in the EchoView help file. Next picture we'll look at quickly is the tape measure tool. This tool has been in EchoView for quite some time. In our EchoView toolbar, it's the cute little tape measure icon, which we can see up here. This tape measure tool just now reports more metrics than it previously did. So if I select this tool and make a measurement on this echogram, I now get 5 different measurements. And these algorithms, as with all EchoView algorithms, are fully documented in our help file. So if I press help contents, if I search for tape measure, one of the results is about measuring distance. And these are the algorithms that are used to calculate the 5 measurements that were shown in EchoView or also on this slide. So all fully documented, of course. Missing data files, I'll do a demonstration for this one. Missing data files, certainly here in the office, drive us crazy sometimes. It's a real pain when you open an older EV file and data files have been moved on the server and then we have to try and find them. And so I'll show you what happened in EchoView 9 if data was missing. So I'm going to open an EV file where the data can't be found anymore. I'm sure we're all quite familiar with this little pop-up message that says can't be found, do you want to specify an alternative location? Right now I don't. I click no, and I have to click no quite a few more times for every single data file that's in this EV file before I can actually open up the EV file. If you have an EV file with hundreds of data files, this is not much fun. So EchoView 10, if I open that same EV file, we get one pop-up message, which is optional. We can choose not to have this pop-up at all. That gives us a preview of all the data files that couldn't be found. I only have to OK this once, and then the EV file opens. And then once I can right-click on any of these data files in this list here and use the new Browse for File option and tell EchoView where my data has moved to, and everything's back to normal again. So it's just one of those small little adjustments to try and make everybody's life a bit easier. So that's all the demonstrations that I'm going to do for today. There is, of course, a whole lot of other new features in EchoView 10, which are all well described in our help file. And you can see the full list of changes that are both general and also specific changes for particular Echo Sounder makes and models. So in our help file, we can just go to the contents, introduction, and then we've got our new for all users page, as well as pages for the Echo Sounder specific changes, which in this case is ASL, FlexView, and Simrad Echo Sounders. So we always encourage people to have a good read of this with every new release that we make available. If you do have any questions about new features, please feel free to email us via support@echoview.com, as we're always happy to answer your questions about new features or old features, of course. And as a reminder, we also really encourage people to make sure we're always using the latest version of EchoView. So when we release a new version like EchoView 10, we'll make updates after the initial release that might fix some small bugs or make some more changes. And so to see if you have an update available in EchoView, you can see I'm not using the very latest version. So in the top right button, it says update available. If I click on this, or if I go help, check for updates, the EchoView updater will open and it will tell me what's available compared to what I have. So currently available is 10.0264, but I've only got 10.0.257 installed, and I can click view the release notes to see what's changed since the initial release that I have. So we always recommend that people make sure you're working with the very latest version. In this case, we've made some changes specific, particularly for the ICs export, which I didn't demonstrate today, but we've made some adjustments to that based on feedback from people who have been using that. So before I wrap up, did anybody else have any questions that they would like answered? If you do, feel free to send through in the chat message, or otherwise send me an email after this meeting. Thank you very much for participating. We're really excited to have EchoView 10 now available for use, and we've got some great feedback on it so far. Please don't hesitate to get in contact with us if you have ideas or requests for new features in the future versions of EchoView. We're currently working very heavily on EchoView 11, and we're really looking forward to bringing you another exciting release when that's ready. Thank you very much.